All right, like terms are algebraic terms. They have letters in them. The letters have to be the same. The powers on each same letter have to be the same. The location of each letter has to be the same to be like terms. Let me give you a couple examples of what like terms are. 2x and 3x are like terms. They both have x the same letter. Both x's are to the first power, and both x's are in the numerator if they were in fraction form. So they're in the same location. 7x squared y to the third over z, and 10x squared y to the third over z are like terms. They both have x's, x's are both squared. They both have y's, y's are both cubed. They both have z's, z's are both to the first. The x's are on the top, the y's are on the top, the z's are on the bottom. So, same letters, x, y, z, same powers, x is squared, y is cubed, z is first, same location, x on top, y on top, z on bottom. Okay, those are like terms. Like terms are allowed to be added and subtracted legally. All right? Here's a non-example of like terms. Non-example. So these are not like terms. 4xy and 7x. What's wrong with that?
There's no y.
There's no y. So the same letters aren't there. They both have x, but this one has y, that doesn't. Those aren't like terms. 4x squared y and 7xy squared. That's not. Why not? The powers are messed up. All right, they both have a square and a first power, but this x is squared, this x isn't, that y isn't squared, that y is. So the powers aren't the same. 4x over y and 7y over x. They both have x and y. They're both the first power, right? That's x on top, that x on bottom, that y on top, that y on bottom. So they're not the same locations. Okay? These two right here actually don't have the same powers. If we want to get really technical about it, if we wanted to avoid this same location idea, this is actually 4x y to the negative first and 7y to the negative first x. Or sorry, I wrote that wrong. All right, let's try again. 7y, dang it. 7y x negative. There you go. So this is actually x to the first, x to the negative first. The powers actually aren't the same. They look like they're the same. First, 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 first. But this is actually negative first. That's actually negative first. So if you want to avoid the same location thing, if you just imagine everything as a positive or negative power, you can do that. I think it's easier just to do the same location. Just have that third check. So bottom, top doesn't work. They're not like terms. All right. When we go to add like terms, use the power rules that we just dealt with yesterday. X times x, you add the powers. X divided by x, you subtract the powers. X squared to the third, you multiply the powers. If you have negative powers, you move them. If you have 0 powers, you make them equal 1. So basically, if it's being multiplied, just throw it out. Use those rules that we did yesterday to simplify every single term. Terms being separated by pluses and minuses. So all this stuff plus all this stuff plus all this stuff. Simplify this, simplify this, simplify this. After you simplify every term, then you see if they're like terms. Do they have the same letters, same powers, same locations? If they do have like terms, algebraically add the coefficients of the like terms. For example, if I have 7x minus 3x plus 10x, 7 minus 3 is 4 plus 10 is 14. Put the variable sequence that made the like terms like on that sum. X is the sequence, right? X. Do not change the powers when adding like terms. I've seen too many people say 14x cubed. Because x plus x in their mind makes x cubed. X cubed is made by multiplying letters, not by adding letters. So, when you're dealing with like terms, this many x's subtracted by that many x's added to that many x's makes that many x's. What made them the same is what is going to be put on the answer. Alright? This is in bold print, written big, with an exclamation point, because, believe it or not, people have done this. They've made this egregious error where they do this, put an x cubed on it, and they don't know why they get the wrong answer all the time. So do not be the person that made me put this in bold print, capital letters with an exclamation point, with bigger font, and all this stuff. So, alright? Okay. Example 3. Simplify by adding like terms. Again, this is a skill we dealt with last year, and this is the end result of the problems we solved. We solved problems like this towards the end. We eased into the problems like this. We started off with this kind of problem. Eventually got to these ugly ones. Some of you, again, were masterful at them. You got them right all the time. Others of you had struggles with them. So again, if we follow the process I just laid out there, job one, identify the terms. This is a term. This is a term. This is a term. And this is a term. Notice I didn't circle the pluses and minuses. Pluses and minuses separate the terms. All right? So identify all the different terms and make every one of those terms as simple as possible. That means I've got one of each type of letter, all powers positive. So any term that isn't like that, we need to fix. Let's start with Quinn, the blue term. Is there anything wrong with that? Very good. Quinn just noticed that a is to the negative second power. We don't want negative powers. So the 3 is fine, the b is fine, the c is fine, the a squared belongs in the bottom. I recommend alphabetical order. It's not required, but for me it's easier to compare things if they're all in the same order. So if I got a first, c second, that's great. All right. Maddie, second term. I got a minus sign here. I'll put the minus sign, there's the fraction bar. Is there anything wrong with the second term?
No.
No. That's exactly right. There's one a, there's one c, there's one b. All the powers are positive. Everything's good about it. So 4b over a squared c. Everything's perfectly fine about that. The minus sign makes the 4 negative. It does not move anything up or down. Negative powers create that situation. So this negative power moved it down. This negative 4 is just the number negative 4. It's to the first power. The power is positive. It's where it belongs. Let's go with Delilah. What's wrong with the third term?
A to negative second is going to run into the c to negative first.
Perfect. Okay. So we have no fraction structure. So officially this is over 1. These two guys have negative powers. They both belong in the bottom. The 7b is fine where it's at. So 7's fine. B is fine. A squared belongs in the bottom. C to the first belongs in the bottom. Braden, what's wrong with the purple one?
Nothing.
Nothing. B is to the first power, A is to the second power, C is to the first power, everything's positive power. This is just a negative 4 that's got a first power officially on it, so it's not a negative power. So everything where it belongs. I'm going to rearrange it so it's alphabetical order. Again, I would prefer alphabetical order, so that's the one thing I would do to change that. But again, everything's still in the same location, top and bottom. That is priority 1. If you do that one step, you've made the problem 100% easier. Okay, you can tell like terms much easier when everything's the same type of structure. Kaylin, are there any like terms in this?
Yes, the first 3 are like terms.
Very good. Let's go with Rachel. Why is the last one not a like term?
Because a squared is on the top and the
Perfect. Okay. Everything here has a squared, b, and c, right? A to the second, b to the first, c to the first. But this a squared's in the wrong place. It's supposed to be on the bottom, it's on the top. So these 3 guys are like terms. This is not. Which means that these 3 terms can be added or subtracted as we need to. This term cannot be. It's a separate term for the final answer. So the final answer, all I can do is make these into one thing, keep this as one thing, and stick that as my answer and be done with it. So if I add up all the stuff circled in this black marker, 3 minus 4 plus 7 makes 6, right? The variable sequence that made them the same was b on top, a squared, c on the bottom. A squared. Tell you what. A squared, c. My marker really is not cooperating with my hand, which is not cooperating with my brain. So b over a squared, c made them the same. So the numbers, 3 minus 4 plus 7 made a new number. The variable sequence stays the same that made them the same. Again, no powers changed. I only just rewrote what the variable sequence was. And then I got this other guy here, minus 4 a squared b over c. I can't do anything to make that any prettier. That's the final answer. Stop there. Okay, that's all adding like terms is or ever will be. Again, the problems are going to start off right at this level. Fix every single term using all the power rules that you need. There's like, let's say it said 3aabb over c, 3a squared b squared over c. Use power rules, what we did yesterday, to simplify every term. Then find the like terms, then add or subtract depending on the signs, and then circle your final answer. Know that your final answer is going to have multiple pieces to it.